Okay, determine whether or not the given point is inside, outside, or on the circle for the following. So the given point here is 2, 2, and the circle is x squared plus y squared equals 4. Now what I've done here, I've sort of drawn this on the computer, okay, to actually show that circle. And this is a really simple circle, isn't it? Because remember here, that would be like x minus 0 all squared. So it's just x squared. And that will be y minus 0 all squared. So it's just y squared. So the center is 0, 0, isn't it? It's the origin. And because that's your r squared, that means then that the radius will be 2, okay? So the distance is 2 in every direction, okay? Which means then that coordinate 2, 2, well, of course you go across 2, don't you? Which will take you literally there to the circle, edge of the circle. And of course you've got to go up 2, okay? So we can end up here. So clearly you can see there that that's outside of the circle, okay? However, just doing that is not going to get any marks, okay? Because I've just sketched it, okay? And a sketch does not qualify here, okay? We need to do some maths, okay? And it's not difficult, okay? But we've got to show, we've got to justify that in this case the point 2, 2 is actually outside of the circle. We need to justify it. Now all you need to do is first of all consider your circle, right? And you need to write down the center coordinates and the radius. This is part of getting the marks. Now clearly here the center is easy to see, 0, 0, yeah? And the radius, as we discussed, also is the square root of that, so it's radius 2. So you've got to write that down to start with. What you need to do then is take the point, okay, and you need to see how far that is away from the center of your circle. Okay, now the center of my circle is here, the origin. So I need to work out that distance. Okay, so the distance, I would use the formula, of course, from coordinate geometry, of x2 take away x1 all squared plus y2 take away y1 all squared. Okay, it's going to be relatively simple, this one, because the origin is the center of the circle. So you know, that's my x2 y2, so x2 will be 2 there, take away the x1 which is 0, and the y2 is 2, take away the y1 which again is 0. Okay, so work that out, okay, and we get square root of 8, which is 2 root 2. Okay, so what we've shown here now is, right, is that the distance from center circle to the point is 2 root 2, okay, but 2 root 2 is greater than the radius, okay, this is greater than the radius of the circle. Thus that proves that the point is outside, okay, therefore the point is outside of the circle. Okay, hope that's clear to you there. Fact is, the distance to the center is 2 root 2. Okay, from the point to the center is 2 root 2. That's greater than the radius of the circle, so it's got to be outside, isn't it? Okay, so let's look at this one here. Okay, so the center in this case is 3, 4, yeah? Okay, there's the center there, and the radius is 6, yeah, because 36 there is r squared, isn't it? So so then you square root it, so the radius is 6. Now let's see about this point 9, 4. Okay, let's see how far it is from the center. So the distance, okay, again, you know, write that formula down. So if I call this my x2, y2 maybe, and I'll call this my x1, y1, so then it will be that x2 there, 9 take away 3, and then all squared, and then 4 take away 4 all squared. That's quite nice. So if you work that out, it actually comes out to be 6. Okay, the distance from the center to this point is 6. Well, the radius is 6, so that means it must actually lie on the circle. In fact, it's right up here, isn't it? Okay, if you think about it, because that 0.94, okay, is directly above the center, isn't it? Because they've got the same y values there. Okay, or I should write it over here, shouldn't I? That's where it should go there. Sorry, 9,4, and up here. So you're going across 6, aren't you? To get to that point, and the y values are the same. So we say, look, the distance from center to a point is equal to the radius. Therefore, point lies on the circle. Okay,